Okay, today we're going to talk about angle relationships, and we're going to see how you can use angle relationships to solve different geometric problems. First two angle relationships we're going to talk about are supplementary and complementary. Supplementary is when you have two angles whose measures is a total of 180 degrees. So, for example, in this diagram, you'll see angle 1 and angle 2 would be supplementary because the two make a straight line, which is the same thing as 180 degrees. And if that's the case, let's say angle 2 was 105 degrees. Well, since the two make a straight line, which is 180 degrees, it's safe to say that angle 1 must be 75 degrees. And then the other complementary are when you have two angles whose measures equal 90 degrees. Again, here's a diagram of an example of two angles that are complementary to each other. Angle A and angle B both make 90 degrees, and it's indicated by the little 90 degrees symbol. Therefore, let's say angle B was 80 degrees. Well, if angle B is 80, and A and B equal 90 degrees, that must mean that angle A is a total of 10 degrees. The two together make 90 degrees. Two more angle relationships. One, vertical. Vertical is a pair of angles that are opposite from each other, and they're formed by two intersecting lines. So here you can see you have angle A, which intersects with angle B at this point, creating four angles. And since angle 1 and angle 2 are opposite of each other, that means that angle 1 and angle 2 are vertical angles. It also means that angle 1 and angle 2 are congruent, or the same in measure. When you have angles that are vertical to each other, that means that they are the same. So, for example, if angle 1 measured 100 degrees, the fact that angle 1 and angle 2 are vertical means that angle 2 is also 100 degrees. And then the last angle relationship, adjacent angles, are angles that have a common vertex as well as a common side. So if you look at the diagram, we have angle 1 and angle A and angle B. Both of those angles have a common side as well as a common vertex. And since that's the case, angle A and angle B are adjacent to each other. Now we're going to talk more about triangles. What you need to understand is that all triangles, regardless of the type, measure 180 degrees. So, for example, if you have this obtuse triangle and they give you the measurement of 2 degrees, knowing that all three must measure 180, we could find x. We'll set all three angles equal to 180 degrees. Then we would combine our like terms, 125 and 35, to get 160 plus x equals 180. Now you have a one-step equation. You should remember to do the opposite operation, and you'll figure out that x must be 20 degrees. Now, sometimes they'll put all this together in one problem and ask you to find missing angles. For example, in this picture, they're telling you that you have a triangle and a line, but you have two angles that are missing. You have to find both of those measurements. Well, you might want to start by finding angle B first. If you look at angle B, it is part or adjacent to the 45-degree angle as well as the 50-degree angle, and all three make a straight line. And since that's the case, we'll set all three equal to 180. Because remember, 180 degrees is equivalent to a straight line. After that, you combine your like terms, and what you have is 95 plus angle B is 180. Again, you're back to solving a one-step equation. Therefore, B must be 85 degrees. And once we have found that B is 85 degrees, you will plug that into the picture. Remember that all triangles equal 180 degrees, and set those three angles equal to 180 degrees. After doing that, again, you would combine, or substitute rather, what you found for B, which was 85 degrees. Then combine your like terms. Once you've combined your like terms, you will then solve the one-step equation to find that angle A is 20 degrees.